Hi, I'm Alex, and right now I'm going to teach you a little bit about collision theory. Now, collision theory was theorized about 100 years ago when German and British scientists Max Strunz and William Lewis published two separate theories about the phenomenon in 1916 and 1918. But before we go into what this theory is, we're going to talk about my friend John. Now, John is a ninja. However, he was born without any legs, so getting to school can be quite the hassle to him every morning. Now, he lays out his pants like this, and, being a ninja, he finds that the easiest way is to jump into them. But today, he woke a little bit grumpy, and when he tried to jump, he landed head first. Now, he can't go to school like that, so he eventually got himself out and tried again. However, this time, when he tried to jump, he landed a little bit too short and didn't jump with quite enough force. And he ended up not even making it into his pants, so he had to try again. Now, third time is the charm. So this time, he mustered up a lot of courage. And finally, he was able to jump with enough force to land in the pants, and he was properly oriented so that he landed feet first instead of head first. Now, the same sort of thing happens in reactions, and it's the reasons why reactions don't happen spontaneously. Now, in order for reactants to actually produce products, they need to fit two checklist items. First, they must react in the proper orientation. This means that you can't land head first in your pants. And then second, they must land with the correct or sufficient amount of kinetic energy. Now this means that he has to jump far enough to reach his pants. Now, to get proper orientation, we can picture an aqueous model. Let's picture a molecule, any molecule, as long as it has a polar hydrogen, this end. Now, in this container, we'll also put a fluorine molecule. Now, you may know that hydrogen mixes with fluorine sometimes to produce a weak acid, hydrofluoric acid. Now, hydrogen fluorine, as it's also called, is a little bit unstable, but fluorine will still want to rip this hydrogen away. However, when they collide, they cannot react because this hydrogen is way too far from this fluorine. This is just like landing head first in your pants. In order to properly orient this molecule, we'll just need to flip it. Now, I don't know what the rest of the molecule actually look like, so we're just going to guess. However, now that the hydrogen's in the right spot, they can actually react, producing hydrogen fluorine. Now, to have proper kinetic energy, this one's a bit easier to understand. You just need to have enough strength in your reaction to break the bonds, the intramolecular forces inside each molecule. So we can picture hydrogen and oxygen in a container reacting to form water. However, they're both diatomic molecules, so they have 2 molecules per mole. This means that there are intramolecular forces in between the molecules. Now, in order for them to actually produce H2O, they must react with enough energy to break the intramolecular bonds inside of them, ultimately forming 2 water molecules. Now, this happens constantly as gases constantly bounce off sides of containers, bounce into each other, exchange, lose, and gain energy within a container, but it does not happen spontaneously. So collision theory